Normandy countryside, June 1944, 2 days after D-Day. A British commando team lies motionless in the dark, 50 yards from a German munitions depot. Between them and their target stands a 10-foot fence of heavy-gauge wire, patrolled by guards with dogs every 15 minutes. Standard wire cutters would take 30 seconds and produce a distinctive metallic snap that carries 200 yards in the still night air. 30 seconds they don't have, a sound they can't afford. The team leader reaches into his pack and produces something that looks absurdly ordinary, a pair of cutters barely larger than pliers. But these aren't ordinary tools. He positions the jaws around the first wire strand and squeezes. The wire parts with a whisper, not a snap. A soft sound like fabric tearing, barely audible 10 feet away. He moves to the next wire. Same result. In 90 seconds, they've cut a man-sized hole through the fence in near-perfect silence, while guards pass just yards away, completely unaware. By dawn, the depot is a smoking crater. The Germans find the fence breach and assume it was cut hours earlier, perhaps even days before. They never suspect commandos sliced through it minutes before the attack. And they certainly don't understand how wire that thick could be severed so quietly. The British had a secret, a cutting tool so brilliantly engineered that it violated every assumption about how metal cutting tools must work. It didn't snap wire, it sliced through it like butter. And in the shadows of occupied Europe, that silent slice saved thousands of lives. But how do you cut steel wire without making the noise that typically accompanies metal failure? And why would such a simple tool become one of the most requested pieces of equipment by every SOE agent and commando unit in World War II? From 1940 onward, Britain faced a fundamental problem in occupied Europe. Nazi Germany had surrounded every valuable target: supply depots, communication stations, airfields, rail yards, power plants, with wire fencing. Sometimes single barriers, often multiple layers. The wire was heavy gauge, tensioned tight, and designed to slow down attackers long enough for guards to respond. For resistance fighters and commandos, these fences were death traps. Cutting through them announced your presence and your exact location. The metallic snap of severing wire carried incredible distances at night. Guards were trained to recognize the sound instantly. Traditional wire cutters worked through brute force leverage. Hardened cutting edges forced together, crushing and snapping the wire between them. The snap was inevitable. It's the sound of metal failing suddenly under pressure, the crystalline structure fracturing all at once. Physics dictated it had to be loud. Every manual on night raids emphasized the same grim reality. Cutting wire meant making noise, and making noise meant high casualty rates. Commando units accepted this as an unavoidable hazard. The SOE decided it was unacceptable. Enter Station 9, the SOE's Hertfordshire research facility, where Britain's most inventive minds worked on solving impossible problems. In early 1941, they received a directive from Baker Street headquarters. Develop a wire cutter that operates silently. Not quietly, silently. A tool that could sever heavy-gauge steel wire without producing the characteristic snap that alerted sentries. The engineers initially thought the request was absurd. Metal failure is inherently noisy. You can't change the physics of material fracture. But one engineer, a metallurgist named Captain Lawrence Wright, had a different idea. What if you didn't fracture the wire? What if instead of forcing it to snap, you sliced through it the way a knife cuts rope? The wire would part gradually rather than failing catastrophically. There would be no sudden release of tension, no abrupt structural failure, no sharp crack of breaking metal. Just a clean, progressive cut that produced minimal sound. The theory was elegant. The execution would prove to be one of Station 9's most brilliant achievements. and the result would become so valued by operatives in the field that demand always exceeded supply. This is the story of how British engineers turned a simple wire cutter into a life-saving masterpiece of silent destruction. The fundamental insight behind the silent wire cutter was understanding the difference between fracturing and shearing. Traditional cutters create two opposing force points that crush wire until its internal structure fails. That's fracturing, and it's always loud. Shearing works differently. It's a progressive failure where the material separates gradually along a plane of force. Think of scissors cutting paper versus tearing paper. One is smooth and quiet, the other is rough and noisy. Captain Wright's team designed cutting jaws with an entirely different geometry. Instead of blunt, crushing edges meeting head-on, the cutters featured razor-sharp beveled blades that met at a precise angle, roughly 22 degrees. When the handles closed, the blades didn't crush the wire between them, they sliced through it with a progressive shearing action that parted the metal gradually. The wire didn't snap, it separated cleanly with minimal vibration and almost no sound. The blade material was critical. Station 9 experimented with various hardened steel alloys before settling on a chrome vanadium steel that could be sharpened to an incredible edge and would maintain that edge through dozens of cuts. The blades were heat-treated to achieve hardness ratings of approximately 58 to 62 on the Rockwell scale, hard enough to slice through steel wire, but not so brittle that they'd chip or break under field conditions. The cutting geometry was equally crucial. The blades featured compound bevels, multiple angled surfaces that guided the wire into the shearing plane and prevented it from slipping during the cut. This geometry ensured that force was applied progressively along the wire's cross-section rather than all at once. Testing showed that this progressive application of force reduced the sound signature by approximately 85% compared to traditional cutters. But blade geometry alone wasn't enough. The handles and pivot mechanism had to be perfect. Any play or wobble in the pivot would cause the blades to misalign, turning the shearing action into a crushing action and destroying the silence. Station 9 engineers designed a precision-fitted pivot with bronze bushings that eliminated all lateral movement while still allowing smooth operation. The handles were contoured to provide maximum leverage with minimum effort, critical because operators needed clean cuts on the first attempt with no sawing or repeated cutting that might produce more noise. The size was carefully optimized, large enough to cut heavy-gauge wire up to quarter-inch diameter, but small enough to fit in a coat pocket or commando pack. The final design measured approximately 8 inches long with handles that could be gripped comfortably even while wearing gloves. Weight was kept to 12 ounces, light enough to carry without burden, but heavy enough to provide the mass necessary for stable cutting action. Station 9 incorporated one more brilliant feature: sound dampening pads on the handle grips. These rubber composition pads absorbed vibrations that might otherwise transmit through the handles to the operator's hands and then to the ground or nearby structures. Every possible sound transmission path was eliminated. The result was a tool so quiet that in testing, operators standing 10 feet away with their backs turned couldn't reliably hear when cuts were being made. You won't believe how these deceptively simple cutters would transform night operations across occupied Europe and save countless lives in the process. Manufacturing silent wire cutters was far more difficult than producing standard tools. The precision required was extraordinary. Blade angles had to be exact within half a degree. Pivot tolerances couldn't exceed a few thousandths of an inch. Edge sharpness had to meet strict standards. This level of precision meant that mass production was impossible. Each cutter required skilled craftsmen working with precision machinery. Station 9 established a dedicated production facility in early 1942, but output remained limited. At peak production, they manufactured approximately 500 cutters per month, nowhere near enough to meet demand from SOE networks, commando units, airborne forces, and resistance groups across Europe. Prioritization became a contentious issue. Which operations deserved the limited supply of silent cutters? The SOE's solution was ruthlessly pragmatic. Silent cutters went only to operations where noise discipline was critical to survival. Deep penetration missions behind enemy lines received priority. Assassination and sabotage teams operating near urban areas got them. Resistance fighters conducting raids in heavily patrolled zones received them. Routine operations made do with standard equipment. This allocation system meant that silent cutters became status symbols among operatives. Carrying one meant you were assigned to the most dangerous, most critical missions. Security around the cutters was extremely tight. They were classified as secret equipment. Agents were instructed to destroy them rather than allow capture. Each cutter was serialized for tracking. Training on their use was restricted to personnel with operational need. The Germans knew the British had developed quieter cutting tools. They'd recovered fragments and analyzed captured specimens, but they never fully understood the engineering principles or replicated the technology successfully. Distribution to occupied territories happened through the standard SOE channels, parachute drops, submarine landings, and courier networks through neutral countries. But the cutter's value meant they were often delivered directly to specific agents rather than included in general supply drops. An SOE operative might receive a single pair of silent cutters along with explicit instructions that they were personally responsible for the tool and must return it if possible after mission completion, or destroy it if capture was imminent. The French resistance, particularly networks in urban areas like Paris and Lyon, received significant allocations. Cutting through perimeter fences was essential for raids on German facilities in cities where the sound would carry to nearby buildings and alert not just guards, but potentially hundreds of soldiers in adjacent barracks. Norwegian resistance groups operating in the mountainous terrain also received priority. Sound carried enormous distances in those environments, making silent operations critical. By 1944, demand had grown so intense that Station 9 authorized limited field manufacture. Resistance networks with access to precision machine shops received blueprints and specifications to produce their own versions. Quality was variable. Some field-manufactured cutters matched Station 9 standards, others were crude approximations. But even imperfect silent cutters were better than traditional tools for night operations. The production challenges meant that silent wire cutters never fully equipped all British forces or resistance networks. They remained specialist tools, carefully allocated and jealously guarded. But in the hands of skilled operators on critical missions, they proved invaluable, and the operations they enabled would demonstrate their strategic importance far exceeded their simple appearance. Operational successes in the field. The first major operational success came in Norway, autumn 1942. Operation Grouse, the reconnaissance mission that preceded the famous Vemork heavy water plant raid, required 4 SOE agents to cut through multiple wire fences while German guards patrolled nearby. Using silent cutters, the team severed over 30 wire strands across 3 separate fence lines without alerting the garrison. The reconnaissance gathered critical intelligence that made the subsequent raid possible. The agents later reported that without silent cutters, they would have been detected and killed before completing their mission. In France, the resistance used silent cutters extensively for sabotage operations against railway infrastructure. A typical operation might target a marshalling yard surrounded by wire fences with guard towers positioned at intervals. Resistance fighters would cut entry points in the fence, plant explosives on locomotives or rolling stock, then exit through the same holes, all conducted in near silence. German after-action reports from dozens of these incidents note confusion about how saboteurs penetrated security without triggering alarms or alerting sentries. One particularly audacious operation occurred in Paris, March 1944. A resistance cell targeted a German signals intelligence facility and a commandeered office building. The building was surrounded by wire fencing that had been electrified at the top strands but not the bottom, a common German security measure. The resistance team used silent cutters to sever the bottom strands, creating an entry point beneath the electrified section. They infiltrated the building, destroyed encryption equipment and codebooks, and escaped before the alarm was raised. The fence breach wasn't discovered until the following morning. The Germans never understood how attackers penetrated the perimeter without triggering the electrical alarm system. British commando operations after D-Day made extensive use of silent cutters. Small units conducting reconnaissance behind German lines regularly encountered wire obstacles. Standard procedure was to cut through quietly rather than attempt to climb over or bypass, which took longer and increased exposure time. After-action reports consistently praised the silent cutters, with one commando officer writing, "These tools have probably saved more lives in my unit than any other piece of equipment we carry." The Italian campaign saw creative applications. Partisan groups operating in urban areas like Milan and Turin used silent cutters to breach factory perimeters before sabotaging German war production. One group reported cutting through fences at a locomotive repair facility, disabling 6 engines undergoing maintenance and escaping, all while German guards maintained their patrols, completely unaware that intruders were operating inside the compound. SOE agents in Denmark used silent cutters for a particularly clever operation. They cut small holes in perimeter fences at German facilities, then left the holes unrepaired but concealed. Days or weeks later, other operatives would use the same holes for follow-up attacks. The Germans, upon discovering sabotage, would find the fence breaches but couldn't determine when they'd been cut. Security investigations focused on personnel who had recent access, while the actual perpetrators were long gone, and new teams were using the old entry points. Perhaps the most significant impact was psychological. German security forces became paranoid about fence integrity. If attackers could breach wire barriers silently, then perimeter defenses were essentially meaningless. This realization forced the Germans to implement expensive additional security measures: more guards, more frequent patrols, additional barrier layers, alarm systems, guard dogs. Resources that might have been deployed operationally were instead consumed by security overhead, all because a simple pair of wire cutters made their defenses unreliable. Little did the Germans know, the British were continuously refining the design based on field feedback, making each generation of silent cutters even more effective. Evolution and field modifications. Operational experience drove continuous improvements to the silent cutter design. Early versions worked superbly on fence wire, but struggled with barbed wire. The barbs would catch on the blades and create rattling sounds as they broke free. Station 9 developed a modified jaw geometry with recessed channels that captured and contained barbs during cutting, eliminating the noise. This barbed wire variant became standard issue by mid-1943. Field operatives also requested versions with extended handles for increased leverage when cutting particularly heavy-gauge wire. Station 9 produced a heavy-duty model with 10-inch handles that could sever wire up to 3/8 inch diameter, substantially thicker than standard fencing. These heavy-duty cutters were issued primarily to commando units expected to encounter reinforced military barriers. Durability emerged as a concern. The razor-sharp blades that enabled silent cutting would gradually dull with use, especially if operators cut wire with rust, grit, or other contaminants. Dulled blades required more force and produced more noise, degrading the tool's primary advantage. Station 9 addressed this by including small sharpening stones with each cutter and training operators in field maintenance. Properly maintained cutters could make over 100 cuts before requiring factory refurbishment. Some resistance groups improvised their own modifications. French metal workers added spring-loaded blade guards that protected the cutting edges when not in use. Norwegian resistance fighters developed leather sheaths with quick-release straps for rapid deployment. Danish groups experimented with coating the blades in grease to reduce friction and further diminish sound, though this proved messy and attracted dirt that accelerated blade wear. The most significant evolution came in late 1944 when Station 9 developed an insulated version for cutting through electrified fences. German forces increasingly electrified their perimeter barriers, making fence cutting extremely dangerous. The insulated model featured rubber-coated handles extending up to the cutting jaws, and the blades themselves were designed to sever wire without creating electrical arcs that might produce visible sparks. Testing showed the insulated cutters could safely cut through fences carrying up to 10,000 volts, more than sufficient for typical German security systems. Station 9 also produced specialized training cutters with deliberately less sharp blades for instructional purposes. Trainees could practice the proper technique without risk of injury, then transition to operational tools once proficient. This training program significantly improved field performance and reduced incidents of improper use that might compromise the cutter's silent operation. By war's end, Station 9 had developed 7 distinct variants of the silent wire cutter, each optimized for specific operational requirements. The core design remained consistent, those precision-sharpened blades meeting at the critical angle, but the variations demonstrated how a simple tool could be refined into a family of specialized instruments. German countermeasures and failure to replicate. The Germans captured silent cutters as early as 1942, but their attempts to understand and replicate the technology failed repeatedly. Metallurgical analysis revealed the blade composition and hardness, but German engineers couldn't determine the precise blade geometry that enabled silent cutting. Their reverse engineering attempts produced tools that were quieter than standard cutters, but still far noisier than the British originals. The German failure stemmed partly from misunderstanding the fundamental principle. They assumed the silence came primarily from blade material, rather than geometry and cutting action. German-manufactured copies used high-quality steel but retained conventional crushing jaw designs. The result was slightly quieter crushing rather than true shearing. These inferior copies saw limited distribution to German commando units, but never achieved the performance of British originals. German security forces implemented various countermeasures against silent fence breaching. They increased patrol frequency around perimeter fences, hoping to catch intruders in the act rather than preventing fence cutting. They installed tension-sensing wires that triggered alarms when cut, though these systems were expensive and only deployed at the highest security facilities. Some installations used multiple fence layers spaced several feet apart, requiring attackers to cut through more barriers and spend more time exposed. The most common German response was to accept that perimeter fencing was a porous defense and rely instead on defense in depth, guards, dogs, searchlights, and layered security zones. This defensive philosophy consumed enormous resources. A single facility might require 50 or more guards to maintain adequate security against attackers who could silently breach the perimeter. The economic burden was substantial, particularly as Germany's manpower situation deteriorated in 1944 and 1945. German intelligence services issued repeated directives demanding information about British silent cutting technology. Captured SOE agents were interrogated specifically about their tools and techniques. Several resistance members died under torture rather than reveal details about the cutters. The Gestapo never obtained complete technical specifications, though they accumulated enough fragmentary information to understand the basic principle of shearing versus crushing. By late 1944, German security manuals acknowledged that perimeter fencing was an inadequate defense against determined attackers with proper equipment. The manuals recommended treating wire barriers as deterrents and alarms rather than actual obstacles. This represented a significant psychological victory for Allied forces. The Germans had effectively conceded that their static defenses could be silently penetrated at will. Legacy and post-war impact. The silent wire cutter's influence extended far beyond World War II. Post-war special operations forces worldwide recognized the value of quiet breaching tools, and development continued. Modern bolt cutters and wire cutters used by military and law enforcement incorporate many principles pioneered by Station 9's design: precision blade geometry, compound bevels, optimized leverage ratios, and sound-dampening materials. The British Army continued manufacturing updated versions of the silent cutter through the 1950s and 1960s, issuing them to SAS and commando units. These later models incorporated modern materials like hardened tool steel alloys and synthetic rubber grips, but the core design remained remarkably similar to the World War II original. Some variants remain in service today, testament to the enduring soundness of the basic engineering. The tool influenced civilian applications as well. Professional locksmiths and rescue services adopted similar blade geometries for quiet cutting operations. Aviation rescue teams use precision cutters based on similar principles for extracting crash victims without creating sparks that might ignite fuel. Utility workers employ quiet cutting tools for electrical line work where noise might be hazardous or disruptive. In the broader context of special operations history, the silent wire cutter exemplifies a critical principle. Sometimes the most important innovations aren't weapons themselves, but the tools that enable weapons to be deployed effectively. The cutter didn't kill anyone directly, but it enabled thousands of successful operations that couldn't have been conducted otherwise. It saved lives by preventing detection. It achieved strategic effects through tactical advantage. Military historians studying World War II resistance operations frequently cite silent cutters as among the most requested and most valued pieces of SOE equipment, despite their apparent simplicity. Agents who used them in the field consistently reported that the psychological confidence of knowing they could breach perimeters silently was as valuable as the actual capability. Fear of detection creates hesitation and mistakes. Confidence enables bold, decisive action. The tool also demonstrated the value of listening to field operatives. Station 9's development of silent cutters came from operational feedback. Agents and commandos reporting that noise during fence cutting was getting people killed. The willingness to take that feedback seriously and invest resources in solving what might have seemed like a minor technical problem exemplifies the SOE's operational effectiveness. They understood that small advantages compound into strategic superiority. For the engineers and craftsmen who designed and manufactured these tools, recognition came slowly. Most were bound by secrecy classifications that prevented them from discussing their work for decades. Captain Lawrence Wright, whose metallurgical insights made silent cutting possible, received no public recognition until the 1970s, when partial declassification allowed his contributions to be acknowledged. He died in 1982, having spent his post-war career in relative obscurity, despite creating one of the war's most impactful specialized tools. The silent wire cutter was never glamorous. It didn't shoot, explode, or destroy. It simply cut wire quietly, a mundane function elevated to life-saving art through brilliant engineering. But in the shadows of occupied Europe, where survival often depended on silence, this simple tool became as valuable as any weapon. It transformed impossible missions into achievable operations. It gave commandos and resistance fighters the confidence to operate deep behind enemy lines, and it proved that sometimes the most powerful military innovations are the ones that solve small problems perfectly. The next time you see a simple pair of wire cutters, remember that during World War II, British engineers turned that everyday tool into something extraordinary, an instrument that could slice through steel in near silence, defeat Nazi security measures, and save thousands of lives through nothing more than precision blade geometry and brilliant design. That's the true legacy of Station 9's silent cutter, the reminder that innovation doesn't always mean complexity. Sometimes it means taking something simple and making it perfect. If you're fascinated by these ingenious British innovations that won World War II through cleverness rather than firepower, you absolutely must watch our previous videos. Discover the L-delay sleeper explosives that waited months before detonating, destroying German equipment long after saboteurs had vanished. Learn about the thermite incendiaries that burned so hot they turned ammunition dumps into infernos that water couldn't extinguish. And don't miss the well-rod pistol, the suppressed assassin that let agents kill Nazi officers in complete silence. Each of these weapons shared the silent wire cutter's genius. They were simple, devastating, and absolutely brilliant. These are the secret tools that helped defeat the Third Reich, and their stories deserve to be remembered. Subscribe to this channel right now to discover more forgotten innovations from history's shadows. Hit that subscribe button. You won't want to miss what we're uncovering next about the brilliant minds who turned everyday objects into war-winning weapons.